my screen. Okay, hello everyone. Thanks for joining. I will give this presentation about Java and JavaFX on the Raspberry Pi and the Pi4J library. Let me introduce myself. I live in Belgium, so we're in the same time zone, which is always great for a talk. I do a lot of blogging on webtechy.be and also on fuji.io. If you don't know this Fuji website, please do check out. It's a great big resource of Java stuff, and every day we have an article there. And I also blog there about Raspberry Pi and Java on the Raspberry Pi. It all started for me, the programming stuff, when I was 10 years old, a long time ago, with this Commodore 64. I used it to control my Lego trains even, and all that kind of interesting stuff where I combined software and hardware. And now, so many years later, I'm doing a bit the same, but now with the Raspberry Pi. I work at Todi, that's a Belgian company, startup, where we built these automatic lawnmowers. They work with artificial intelligence, so they don't need the perimeter wire, but they work with vision, so they have a camera inside, and I do their Java backend development. But I'm also a Code Dojo coach. If you don't know this, this is a club for kids between 6 and 18, where they learn to program, but they also learn to work together and experiment and share knowledge and present what they're working on. And the special thing about this Code Dojos is that we work with volunteers. All the coaches are volunteers, and they bring their own knowledge to these events. And that's actually where I learned to work with Raspberry Pi and Arduino, these very cheap electronic components, which are very powerful. So some coaches bring this to these events to show to the kids and to learn how to work with it. But of course, also the volunteers learn by watching the other coaches. And that's how I ended up building this drum boot for my son. So he has a touchscreen user interface, which is actually JavaFX. At the back, it has a Raspberry Pi, so this application is running on a Raspberry Pi. It's controlling two relay boards. It's also controlling an Arduino. The Arduino is driving the LED strips. Then you have different relays for 220 volt and 15 volt to control these different lights. And because it's Java, you can also implement very easily a web interface. So we have this web interface that we can start the red signal, which means that he has to come down for dinner, as he never hears us scream from down the stairs, of course, as he is drumming. So all this Java project that I created, it was all new to me. So it was new. I was doing Java for 10 years, but I never did Java on embedded and with electronics. So I started writing about this, blogging, a 4-page article for Magpie magazine, and it ended up in this book. So all my experiments to end up on this final application are described in this book, together with a lot of other information and documentation about Java, about the history, and so on. We'll not go too much into detail, but there's a lot of info there. So what is the Raspberry Pi? For people who don't know it, it's full PC in a very small size, and a low cost. So the biggest Raspberry Pi is 9 centimeters, the smallest is 6.5. So you have these different versions, a bit depending on which connections you have on there. So you have the A and the B. The B is the most used one. You have them in 2, 4, and 8 gigabytes of memory, between 35 and 85 euros, I think. And then you have the very small one, which you can use for like cameras or small projects. Now, there's also a special one, is the compute module. And if you are into embedded development, but you really need a full PC into your own product, then the compute module is something you should take a look at. Because the idea is that you have all the PC components on this small board, and you have to connect it with a baseboard. Now, there is a baseboard provided by the Raspberry Pi Foundation for 35 euro, and you see that it has all possible connections which are available together with this compute board. But if you are building your own device and you only need, for instance, a network and a screen connector, then these are the only ones that you wire or foresee on your own board. Now, this compute module comes in 32 versions, depending on if there's Wi-Fi, no Wi-Fi, how many memory you want on it. So you have them from 30 until 90 euros, I think, between those price ranges. So this is really a very nice and useful tool as a PC to integrate in any product. On the other hand, they also redesigned the Raspberry Pi 4 to fit into a keyboard. So this keyboard already existed, is the official Raspberry Pi keyboard. And they integrated a Raspberry Pi 4 inside this keyboard. So for 85 euros, you have a full PC. You only need a mouse, a screen, and a power supply, and you plug in an SD card with the operating system, and you're good to go. And you have, again, these pins, we will see about these later, where you can connect electronic components. Now, this keyboard thing reminded me of what I started with. So this Raspberry Pi 400 and the Commodore 64, they both had this connector at the back. I connected my trains there, but now you can connect LEDs and buttons and whatever kind of sensor you're thinking of, you can connect it here and do some experiments with this. There's one big difference. If you recalculate the price of that Commodore 64 so many years ago, that would now cost almost 1,500 euros. And you have this Raspberry Pi 400 under 100 euros. So for a very low price, you have a lot of flexibility and things you can experiment with. One of the biggest differences is the screen. This was my first Hello World application so many years ago in BASIC. This is what the Raspberry Pi 400 screen looks like, because you can connect two 4K displays to this very cheap computer. So when I was writing my book, I was using Visual Studio Code, I had Arduino open, I had Terminal open. So a lot of applications that you can use. Of course, it's not as smooth as working on a full PC, but you can still do all this stuff on this Raspberry Pi. Now, I get asked a lot, why would you use Java on the Raspberry Pi? Because the Raspberry Pi was designed for Python. So when they were designing this board, Python was the tool that they were using. They wanted a fruity name, so Raspberry, Apple, you know. So they used Raspberry. And the Pi comes from Python and from the number pi, but Java works just as well on the Raspberry Pi. And why? If you are a Java developer, why not use the knowledge you already have to experiment in another world, in the embedded world, and use some electronics? And that's what I actually learned, because at work, my embedded colleagues, they work with I2C and SPI to control devices. I've never heard of that before I started doing these experiments and knew how to control these. Java is dead, is not dead. That's an ongoing discussion. Unfortunately, we're going down in the TOB index, but and that's mainly because Python is gaining a lot of traction in machine learning and AI, but actually all those technologies are also available for Java, and you can use them also in your projects. By the way, we're still in the top 3, and that's a good thing, and we will soon begin increasing again. Java is also eco-friendly, and that's very important for embedded, because C here is the reference. So if you have a similar functionality in C, which takes up 1 energy unit to do its calculation, for Java, it will take almost 2. So there's a very close relation between C and Java. If you look at Python, used a lot on the Raspberry Pi, it uses 76 times that amount of energy for the same kind of function. So also there, Java is something to keep in mind as being a worthy alternative if you don't want to do C. Java being too old is also one of these arguments why you would not use Java in this world. But if you see, Java is actually newer than Python compared to Python, PHP, Qt, they're all the same age. So again, not an argument to not use Java. And what is very important now is this big evolution that we had since 2018 with the 6-month release cycle of Java. And all these new versions and all the new features which are coming out every 6 months, and some of them are really also targeting embedded. Also JavaFX, which is following the same release cycle. There are new features coming into these new versions also for embedded. So that's also one great thing to take into account. As a side note, I needed these graphs of the previous page for my book. I could have done this with Photoshop or Excel maybe, but I'm a programmer, so I made them with JavaFX. If you want to create something similar, it only took me 2 hours to then build these kind of charts with some enum list of all the events. The sources are available if you want to experiment with this. I've written an article last summer for Oracle Java magazine, which shows you how to get started with JavaFX on the Raspberry Pi. So if you want to build an application like this with a distance sensor and some buttons, and it's fully described there, the sources are there. And I have to say that at that summer, this blog post was one of the most liked articles. So a lot of the embedded and of the backend Java developers really like the idea of taking Java into a completely new world. Now, if you get started with the Raspberry Pi, you need an operating system, and the Raspberry Pi Foundation has one prepared for you. It's based on Debian 32-bit. If you go for the full edition, you get OpenJDK 11 pre-installed. So that means that you can do Java development or run Java applications as soon as you've booted your Raspberry Pi. Everything is there to get you started. If you select this full Raspberry Pi OS system, you even get a lot of development tools. Scratch, if you want your kids to learn to program. Minecraft is there also, I think. But Visual Studio Code is a nice addition. It's not pre-installed, but it can be very easily added by just downloading it from the Visual Studio Code website, or it's also there with sudo apt-get. And they have special versions or pre-built versions of Visual Studio Code for both the 32-bit and the 64-bit version of Raspberry Pi OS. On Fujay, I've described how you get the application out. That's very easy, but how you can add some extensions. You can really use Visual Studio Code as a Java development environment. Most of us use probably IntelliJ, but Visual Studio Code is a very nice and free competitor. So as I said, Java is pre-installed. So this is a new Raspberry Pi. I flashed the Raspberry Pi OS to an SD card. I started this Raspberry Pi. The first thing I did, opened the terminal and asked for the Java version. And you see Java is there. It has the JDK 11. And depending on which time you make the SD card, you will have a version 11 or higher. The latest one, which was pulled into the Debian project. Now, JavaFX, as you may know, JavaFX, so to build graphical user interfaces with Java, is not longer part of the OpenJDK. So you need to install it separately. There are a few ways you can do that. JavaFX is maintained by Gluon, a Belgian, mainly Belgian company, and they are the main contributors and maintainers of JavaFX. They have on their website also downloads specifically for the Raspberry Pi. This is the Gluon team, by the way. And with Gluon, with JavaFX, you can build very nice user interfaces. So you have a lot of components already available, the basic components to build a user interface, but there are a lot of others available to build really nice applications with Java and JavaFX. One of my favorites is Han Solo, Gerrit Grunwald TilesFX. It allows you to build very nice dashboard-like applications. So, for instance, if you have a temperature sensor to show the temperature evolution, or a button to control a LED, all this is possible with this library. I think I, by accident, closed the chat. So if there are questions, okay, I have the chat back now. What is also nice as an experiment, one time I built the latest Java from sources on the Raspberry Pi. It takes about 45 minutes, I think, but that means that you can already start using Java 17 or what is now currently in development on the Raspberry Pi if you want to have really the latest state of the art. One of the ways to get JavaFX on the Raspberry Pi is using the Liberica GDK. So Liberica is a Russian company, Bellsoft. They provide also a GDK, and they have one which has Java and JavaFX combined again in this JDK. So that means that you just need to replace your GDK and you can run a JavaFX application just with Java minus jar, and you don't need all the dependencies. That's one of the approaches. Another approach is by getting it from the Gluon website, as I said before, where you can find a version specifically for the Raspberry Pi. They mention here Raspberry Pi 4, but it also works on the 3. And if you take the latest one from Gluon, you have some additional benefits, and that's Java 16 and 17, JavaFX 16 and 17. Introduced direct rendering mode on the Raspberry Pi, which means that you can run your application in kiosk mode, meaning that you disable the desktop and your users are not able to start, for instance, the browser or restart the PC or mess around in the settings. And you can just run your application, which is the only one on the screen, with an extra benefit that the performance, of course, is better because this is the only thing being rendered on the screen. If you look at this is also from Gerrit Grunwald, is a JavaFX sample game. And you see this is running now on a Raspberry Pi at nearly 60 frames per second. So you have very smooth animations and you can create a game running on the Raspberry Pi, a very smooth running application. One of the older features of JavaFX is 3D. So I also experiment with that, and you can see that this runs also smooth on a Raspberry Pi, and you can control a 3D world with your buttons or, for instance, with electronic components if you would like to do so. Another project I want to mention is FXGL. If you don't know this, this is a gaming engine built on top of JavaFX by Almas. You can use it, of course, to create a game on the Raspberry Pi or whatever device you want. I use it also for testing the performance of Java and JavaFX on the Raspberry Pi. So here it's animating, I think, 50 dots at about 30 frames per second. This is with an older version of JavaFX, by the way, so performance will be better now. But all these kind of applications are very easy to build because it's Java and you have all these libraries available and can run on the Raspberry Pi. Okay. If you're interested really in JavaFX, we had in the Fuji Virtual Java Tour, we had a JavaFX talk. It's very well described how what the state of JavaFX is and what you can do with it. Okay, back to the Raspberry Pi. The big added value of the Raspberry Pi is the header. This 40 pins. These pins allow you to connect electronic components. They also allow you to blow up your Raspberry Pi. So you have to be a little bit careful and know what you're doing, but that's what we're here for, and to explain you a bit what is inside this header. I even created a Maven repository, small Java library, which includes the settings, what is all available in this header. And in the book, I extended this with a JavaFX application to show you what's inside the library and visualize everything. But let's look at the 40-pin header of Raspberry Pi, of the latest Raspberry Pis. So you have these 2 rows of 20 pins. Some of them have a constant voltage, 3.3 or 5 volt. They have a ground. And then you have all these GPIOs, general purpose input-output pins, which you can control. You can use to control a device like LED, or read the state from a button or a distance sensor, or control an LCD display. So all these pins are available for use, these kind of usages. And some pins have a reserved protocol, but they can be used in many different ways. So what is this pin? If it's a GPIO pin, that means it has either a true or a false state. And in electronics, this means that the true state, there's 3 volt 3 coming out of the pin, or 0 volt. Or if it's an input pin, you give it 3.3. And that's where you have to be careful about, is some of these pins have 5 volts. So it's not the idea that you connect these pins to a GPIO. That way you could damage your Raspberry Pi. Certainly, if you combine a Raspberry Pi with an Arduino, Arduino is also used a lot in these electronic projects. A lot of the Arduinos work with 5 volts. So there you have to be a little bit careful how you combine them. As you can see in this picture, I have this small board slided on top of these pins, which will help you to identify the pin numbers to address them in your software. But of course, you have these tables also on the internet. Now, these pins, as I said, some have a dedicated protocol, like I2C, SPI, serial, PWM. So some kind of devices like such an 8x8 LED display are available with an SPI connector, a chip in between to control them more easily. So all these kind of interfaces are all possible with the Raspberry Pi. For instance, below I have a very small drawing of a Raspberry Pi connected to an Arduino via serial interface. The Arduino is used to measure a temperature sensor, a light sensor, and then show a JavaFX chart combined based on these measurements. So all these kind of projects are possible with a Raspberry Pi. If you want to start experimenting in this world and you've never done this before, go to eBay, search for an electronic starter kit. You find a lot of them from 20, 30 euros, depending on what kind of components are there. Some a little bit more expensive will have an Arduino. Make sure you have enough resistors, LEDs, the LCD display, a servo, a distance sensor. These are the basic components, but depending on how much money you want to spend, this price can go up a bit. We have some Swiss students doing a project for a Java where they use Java on the CrowPi. CrowPi is, I name it a nuclear missile suitcase, something like that. That's how it looks like, but actually it has a spot where you plug in your Raspberry Pi, and then it has a lot of these basic components for experiments which are pre-wired. So you don't need to worry about how to wire these. You only need to focus on the software. This is also a very nice approach on how to learn Java, Raspberry Pi, and electronics. Now let's dive into some source codes and make a Hello World application. Now, Hello World in electronics, that means a blinking LED. Let's use a LED and make it blink with software. LEDs typically have a certain voltage that they need. And if you have too much voltage, you will blow them up. So we need a resistor in between to make sure that the 3 volt 3 coming out of the Raspberry Pi, if you have a LED which is 2 volt 2, for instance, that only the required voltage is given to this resistor. Now, these resistors in these electronics kits have these color codings. Again, I created a little Java library and a JavaFX demo application to help you to calculate which resistor to use for this project. Now, most of the resistors I use in the examples are 220 or 330 ohms. which is good enough. Maybe it's not the ideal voltage for your LED, but it will light up. Maybe not as bright as it could be, but you will see how it works. And there's also an application and a smartphone app for that. And this smartphone app is a demo application we built for Fuji, which is a JavaFX application using this Java library. And then with GitHub Actions, it is published as a native application for both Windows, Mac, Linux, iOS, and Android all in one go. If you want to read more about this, you can find it on the Fuji site, how you can create a JavaFX application and have it running on smartphone. But that's taking us a bit too far. So this is the experiment we're going to use in this presentation. So we have a LED. It gets 3V3 from the Raspberry Pi from a certain pin. We have this resistor to limit the current so that we don't blow up the LED, and then it goes back to the ground. And on the other side, we have a 3V3 going through the button, and then the button is connected back to one of the GPIO pins. So we have the button as an input, we have the LED as an output. Now we want to control these. This is where they connected to. Not that important, but this is how it looks like. So if you buy yourself such electronic starter kit, you will have a breadboard and a lot of these connector wires. So these are very handy to connect your Raspberry Pi with electronics to set up an experiment and change it very easily. And again, here you see such a stack on board, which makes it easy to follow which GPIO pin number you have to use in your application. Now, once you have set it up, you can try it with the terminal. So the terminal is using pre-installed application GPIO in the Raspberry Pi OS. We tell it to use pin 3 as an output pin. And if we send a 1, a true, then you see that it lights up and you can turn it off again. So this is how we control the LED from the terminal. So it's not yet a program, but we can control it from within the computer. Now for the button, we can do something similar. So the button is connected to GPIO 5, and we tell the system that this is an input pin. Now we can read the state of this pin 5, which is 0 because it's not pushed. Then if we push the button and read it again, it has become a 1. You see? So we are using the terminal to read and write to a GPIO pin and control these electronic components. Now, of course, we can do exactly the same with Java. Without using any libraries or complicated programming, we are just gonna execute these exact same commands as we just did in the terminal, but then send them from Java. So with the runtime, get runtime execute, we say, make this pin 3 an output pin. And then we have this simple loop, which 10 times puts the LED on and off. So it sends GPIO write 3, 1 or 0, and then goes into a loop. So this is just one simple Java file. And because we are using or have Java 11 pre-installed on the Raspberry Pi OS, that means that we don't even need to compile it. So since Java 11, you can run Java files just by giving them the Java file. So if we do that, Java hello GPIO.java, the file we just created, it compiles in the background. That's why it takes some time. But you see that we are now really controlling this LED through Java. So that's really our Hello World application in Java controlling this LED. Of course, that's not how we're used to do Java. We are not normally writing directly terminal commands in our application. And that's where we have Py4j for. So Py4j is a library which uses GNI to call native functions to control these GPIOs. So that means that in our Java application, we have this dependency. We can use plain old Java functions as we are used to use them in Java. And this Java library will call native libraries within the OS to control these pins or read the state from the pins. So that means that we are back to Java programming related to these GPIOs. Now, this library was created by Robert Savage already some time ago. He presented it, among others, at Devox in Belgium some years ago. And it has already some history. So it started in 2012. This year, we had a release 1.3 for Java 8, which added support for these newest Raspberry Pi, so the 400 and the compute module 4. The problem is it depends on Wiring Pi, which is a deprecated native library to control these GPIOs. So it has an unofficial update script because this project was forked on GitHub and the newer version is available there. We also released a version 1.4, which supports Java 11. And it was the first step into a completely new version, because one of the problems with the maintaining of this version 1 is that it supports from within the sources a lot of different components, and maintaining all these components and how to control them has become a very big job, and it was decided to do it differently. So that was one of the problems in version 1, Wiring Pi, so the deprecated library was the other big issue. So the idea was, let's move forward, go fully Java 11 plus, take the modular approach. So we still have to experiment, but that we can build native applications, for instance, with GraalVM. That would also be a nice path to take. Of course, support all Raspberry Pi boards, use a new native library to replace the deprecated Wiring Pi, reduce the code base to make it more maintainable, but it's all work in progress. It uses JPIO as the native library. It's also written in C. It's also well supported and well maintained, and it uses another pin numbering, which is easier to use. This is an overview of version 2. Not going into detail again, but you see that everything is nicely split up in separated blocks, so that maintaining or improving one of the functions is really isolated to one class or one interface, and the whole flow becomes very much easier to understand as a developer if you want to dive into the library itself. So if you want to contribute or extend the library itself. Earlier this year, we launched a new website for Pi4J, and really also focused it on getting started examples. So you will find minimal examples to get started with the blinking LEDs, with the JavaFX application, building a game, controlling electronics. Again, work in progress, but actively working on it. And as you can see, Pi4J is used in a lot of projects on GitHub. I have one example, a real-life example of how Raspberry Pi, a consumer product, can be used for real life in products, sellable products. So this is a medical cabinet. The idea is that someone in a pharmacy, he needs a medicine, he looks it up in the computer, it says it's in this cabinet, and you have to pick it from that box. If you open this drawer, the box is already highlighted in green. If you put your hand in the wrong box, it turns red. So you're really alerted that you're picking the wrong thing. And this is a combination of sensors controlled with Arduino and other controllers, microcontrollers, but the main control is done with a Raspberry Pi. One of the examples of the Pi4J website is this minimal example. You see it's the same example with a button and a LED, but now it uses real Java code and this library instead of executing these terminal commands. So what you will see if you would get the sources of this project, that it contains a lot of documentation. So it's not an application for production, it's really showing the user, if you want to get started with Pi4J, this is why we have this line here and what it really does. And for instance, configuring a button, this is, I think, very well known to Java developers, that you have a builder and you can then define values for certain properties. Like for instance, for a button, we have a certain pin. This is a number value. This is the pin we are going to use. To prevent the button from changing state if you click it too fast, so you have a debounce value, and you can attach a listener. So a listener will be triggered as soon as the button changes. So if it gets an up or a high or a low state, this listener will be fired. So we can, for instance, count the number of times this button has been pressed. So this is all the Java code you need to create a button and to attach a listener. And then this function can get any functionality you want. For the LED, it's a similar thing. So we have a config builder for the LED. And here we have a thread going on. And depending on how many times the button is pressed, this LED will blink faster or slower. Very basic coding, but it's just to show you how you can control a LED, read the state of a button, all with this Py4J library. Now, it's a Maven project, so if you get the sources, actually in 3 lines of code, you should have it running on your Raspberry Pi. So you clone the project, you go into the directory, and you do a actually, you don't need to clean if you just got it from Git, but Maven package will give you the project. In the target distribution directory, when the Maven process has finished, you will find all these files. So it's a modular application. So you have all these modules, Java modules, which are used. And actually, you only have logging and then some libraries of the Py4J project. And you have this run shell file, which will launch the application for you. So you even don't need to type in all the Java stuff. So this is what it's, oops. I hope it runs. Yep, there we have it. Nothing, no rocket science, but just showing you that if you click the button, the LED blinks a bit faster. And I think after 5 times, the application stops. Voila. So you see some wires connected to the Raspberry Pi. In the background, you have the output of the logging. Next slide. Okay. The most advanced application I have in my book is the one for the drum boot of my son, where it's actually using a queue to connect several devices with each other. And that's also the event-driven approach that you see now in a lot of backend services works very well on the Raspberry Pi. So you have Mosquito, which is a queuing system for embedded devices. So it has a very lightweight application running on the Raspberry Pi. So you can have a client subscribing to Mosquito to say, I want to know everything which is happening inside a queue with this name or inside a topic. And then you can have a sender sending something into this queue, and the client will receive it. Of course, because it's a queuing system, you can have a lot of different publishers and a lot of different senders. A sender can also be a publisher. So all these becomes available. And for instance, if you want to create a home automation project, which is one of the main interests of a lot of hobbyists. If you have a pet project, you want to automate your home first. So you could have a lot of sensors sending data into a queue, and on the other hand, you could have your application listening to it and acting on one of these values. Now, in my case, I have a PC with a web browser which can load a web page provided by a Java application running on the Raspberry Pi. I have this Mosquito queue, so if I do something on the web page, it sends an event to the Mosquito queue. This Arduino is actually listening to this Mosquito, and depending on which type of command was sent to the Mosquito, it will start another event or another effect on the LED strip. Now you can have other Java applications running on other PCs or on other Raspberry Pis doing exactly the same, and talking to this Mosquito. And the fun thing is with Mosquito, it has a Mosquito sub and a Mosquito pub test program that you can run in the terminal, and you can see what is happening in this this queue or listen to what is happening in the queue. So these are the test, the install commands, and then you have a subscriber and a publisher all running in the terminal just to show you how this can be done. So the first step was to create a small JavaFX application which can send stuff to the queue and also listens to the queue. My next step was creating a user interface. Again, these circles were borrowed from one of the open source projects of Gerrit Groenwald, Hans Solo, and then the rest is just JavaFX stuff, buttons with some CSS styling, and all this can control the LED strips and all the RLS. And then you have Undertow, which is one of these the several web servers that you can integrate into Java, is used to provide a very simple web interface to select from a few effects. Now, if you combine all this, this is what you get. So you have the JavaFX application here running on a PC, but actually sending events to the Mosquito queue on the Raspberry Pi. On the screen above, you see a terminal listening to the Mosquito just to show you which events are passing. And then by selecting one of the effects on the user interface, you see that the Arduino also received these events and controls the LED strips. And then you have the web interface provided by the Java application to control also these LED strips. Okay, good. I have a few minutes to show you something else. Let's see if this works out. Where is my VNC? Okay, now what I'm now sharing is this is my Raspberry Pi. So this is the Raspberry Pi OS. I have Visual Studio Code. Together with Almas, so the creator of this FXGL gaming engine, we created a very simple game. Actually, it's an idea of my 10-year-old son. He selected some emojis on a website, and I had just to create a game with it. So very easy. And what we did is we have this snake-like game. And I can control it with the arrow buttons on my keyboard, but that's a bit boring. So what we have here, actually, by the way, this is also a Raspberry Pi inside some Lego, but this is my second camera. So we have here a joystick. Now, this is a kit of about 20 euros, I think, and you have this joystick, which is actually, if you can see the red connections inside. So actually, these are just 4 buttons in some kind of fancy housing. And then you have some additional buttons. Now, all this is connected to a Raspberry Pi. And using Java Pi4J, we connected each event of one of these buttons to act as a press on an arrow key of the keyboard. So without really changing the codes, our game now became really controllable. This is a bit messy. Let me see if I can show you this. Okay, I'm a very bad game player, by the way. And through VNC, there is a small delay in between what I'm doing with the joystick and the screen. Okay, but you get the idea, I hope. So what we have here is, again, very cheap electronics with the Raspberry Pi, which also costs you less than 50 euros if you don't go for the biggest one with the most memory. And with some fun coding, you end up with an arcade-like game, and it's only your imagination which limits you. It's not, as I found out, it's not the Java code which will limit what you can do. Is actually that you know how to use it. That's most of the time the issue. but you can build really nice stuff and fun stuff with all this. Now, if you want to learn more about this, the full process of building this snake game has been recorded in 3 video sessions, pair programming sessions with Almaz and me, and they are also described with all the links that you need on fuj.io. Okay, now what did we learn? Now, in my ID, Java, JavaFX, the Raspberry Pi, it's an ideal combination, definitely if you want to do some experiments, do some electronics, and because it's Java with minimal code, you have big results also for the gaming engine with FXGL. And as Java and JavaFX and Py4J are evolving fast now, there is a lot to look forward to and to have fun with. So if you want to learn more, go to Fuj. We have a Raspberry Pi category there. I share all this, of course, on my Twitter and on my own blog. And then, yeah, try it out, have fun with it. Okay. Are there any questions? I see that the chat is empty, so I hope that this is a good result as everything was clear.
So
or that everyone fell asleep.
Stop the recording now, and we'll take